This next exercise is going to take a little more advanced math to get to our answer, but it's still going to use the same basic principle. Because I have an infinite limit of integration, the first step, as always, is going to be to go ahead and rewrite that using a limit. I'm just going to let b approach infinity, and I'm going to integrate from 1 to b. Now this is a much harder integral to do. Right? This is not something where I can just look at it and say what the integral is. So I need to think through the techniques I've learned and try to decide which technique is going to be the best fit. So if I'm going to go down my sheet, I could look for a basic rule on the formula card. I don't really see anything that's a great match for that. I could look for a trig integral. No, it's not a product of trig functions. I don't see a square root or an a squared or a u squared. Hold on though, I do have a polynomial times a cyclical function. Right, the polynomial is 1 minus x, and the cyclical function is e to the negative x. So this tells me I should use tabular integration. So this is a good chance for us to brush up on that. I put the polynomial on the left side, I put the cyclical function on the right side. I start by taking derivatives on the left. So the derivative of this function is negative 1, the derivative of negative 1 is 0. And then on the right, I take integrals. So the integral of e to the negative x is negative e to the negative x, and the integral of that is e to the negative x. So now I'm going to draw in my arrows, starting with a plus and then alternating. So it looks like the answer to this integral is going to be 1 minus x e to the negative x, or sorry, 1 minus x times negative e to the negative x minus negative 1 times e to the negative x. Now I can definitely clean that up some. So let's see what I can simplify. I've got x e to the negative x, I've got negative e to the negative x, and I've got positive e to the negative x. So this term and that term are going to cancel out, and I will just be left with x e to the negative x. Sorry, forgot about that positive sign there. Okay, so that cleaned up pretty nicely. And I just need to evaluate that from 1 to b. So now I'm going to plug in those limits of integration. So I've got b e to the negative b minus 1 e to the negative 1. Okay, I could write this slightly differently. So instead of 1 e to the negative 1, I'm going to write that as negative 1 over e. Okay, that's just a number, so it's not really part of the limit. And now let's see what happens with b e to the negative b. Okay, so I'm just going to try a direct substitution here. If I plug in infinity, I've got infinity times e to the negative infinity, which is essentially infinity times 0. So that, unfortunately, is an indeterminate form. Even worse, it's not one of the indeterminate forms that lets me use L'Hopital's rule. So I'm going to need to do some manipulation so I can use L'Hopital's rule. This is why we just went over all those skills with L'Hopital's rule. Suddenly we're doing weird limits with infinity all the time. So one of the tricks we learned is that, okay, to use L'Hopital's rule, first off, I need it to be written as a fraction. So what if I wrote it as b over e to the b? Right, just taking that negative exponent and putting it on the bottom of the fraction instead. So now it's written as a fraction. If I try direct substitution here, let's make sure it's one of the 5 accepted indeterminate forms for L'Hopital's rule. So if I plug in infinity, I'll have infinity over e to the infinity. And sure enough, that is infinity over infinity, one of the accepted indeterminate forms. Which means now I can use L'Hopital's rule. So I'm leaving alone this guy, it's just negative 1 over e. And now I'm going to do plus the limit as b approaches infinity of, and I'm going to take the derivative of the top and the bottom with respect to b. So the derivative of b would just be 1, the derivative of e to the b would just be e to the b, and now I'm ready to plug in, so we're trying direct substitution again, 1 over e to the infinity, this whole thing just turns into 0. So really my answer is just negative 1 over e plus 0, which is negative 1 over e.